call them just one. The difference between format and enforcing is that, say I have a piece of configuration of a big map that I want to apply on a cluster. I define what that big map looks like in the policy, and if I'm informing, it just tells me whether or not that big map cluster matches what I define in the policy. If I'm enforcing, it'll actually detect that it's different. It'll create it or update it, or just confirm that everything looks good. Some features we mostly in policy add-on is that we support dynamic policies with templating. I'll do a demo specific on that later. We provide secure secrets distribution from the hub to the managed cluster. It can wrap other policy engines, so we can convert to Argo. So basically, in policy engine, you can find the policy in YAML, and the results are shown in YAML. You can wrap those for the ease of configuring it in a multi-cluster way, and reporting back on those policy violations from those policy engines. We also have an extensible collection of policies. I have a link there. It's currently curated by Red Hat, and we're in the process. Red Hat's in the process of donating that to the community, and that upstream. So before going into the demo, I just want to provide some background concepts for policy. So the first building block is really a policy template. So that's a policy to perform a specific action or check. So one example that I'll show you in the demo is a configuration policy. So I want to apply specific configuration to Kubernetes clusters. Policy then groups those policy templates and puts them in the context of security, or it kind of groups those policies together. So one example says if I'm enabling NCB encryption on an OpenShift cluster, I might have one configuration policy that actually goes and configures NCB encryption. Then I have another configuration policy which is informing me whether or not that is successful. So you can examine the status message of the Kubernetes API, the cluster to see if NCB encryption has completed and was successful. So that's one example. So the concept of placement and placement binding. So placement allows you to select those managed clusters that you want the policy to apply to. So dev clusters, applied clusters, or OpenShift clusters. And that's all done through Makelink, which I'll show you in the demo. And then lastly, I won't go into this too much today, but policy sets another grouping mechanism to group policies together. So it's helpful if you have different authors or different personas writing the policies. But then you have, say, an SRE that's deploying a bundle of policies. Policy set is nice in that way. So I'll start off with the first demo, and we're going to have a policy that creates a config map called demo on only clusters in the Boston data center. So here's what the YAML of the policy what it looks like. So you can see first that it's a kind policy with the cluster management. So we're calling it devconf demo policy, devconf demo config map. And here's some annotations that puts this policy into context for the standards that you're trying to apply this to. It's helpful if you, like I said, if you have internal standards that you're trying to meet or external regulatory compliance, it's putting that policy in that context. So you can have policy reporting tools that allow you to run into that, filter by that. Red Hat has a user interface in the productized version of the cluster management that allows you to do that metadata and filter by that. So it can be really easy to say, like, here are my policies that are for my PCI compliance. So here is policy templates array, which I alluded to before. So we just have one policy template here, which is a configuration policy. And here I have it to inform that we must have a config map called devconf demo, and then we just have a Ruby quote in there. There are other options for compliance type, like you have must only have, which would be the same as this, except that it will remove any additional content in the config map. So exactly as it is there, we replace it if it was different. Must have merges things together. Then there's also a must not have, which allows you to delete the config map that placement here. And again, this is what determines what clusters this policy applies to. So in this case, I'm saying that I want my policies to be applied to a data center, or all my clusters that are in the data center of Boston. So I'll go ahead and apply that now, but then I'll show you the environment that we're in. So right now I'm on the hub cluster. And you can see that on the tabs on the right hand side that when I'm on this one, it's the hub, and then I have my two managed clusters that are managed by that hub. So you can see me clicking on this and know which cluster I'm working on. So right now I just showed the managed cluster objects. So these represent the clusters that are registered to the hub. And I have cluster 1, cluster 2. And unfortunately, I zoomed in a lot, so it's not a big wall of text, but what's important here is that there's labels associated with it. So here I've added labels to my managed cluster. And so I have data center is Raleigh for cluster 1. And then I have data center equals Boston for my cluster 2. And that's what allows me to use that placement to select which clusters that I want to use. So you can add arbitrary labels. Some implementations of other cluster management, like advanced cluster management, for instance, they'll auto-populate some things like the OpenShift version that you're using, so you can filter based off of that. So it's really up to you how you want to use, how you want to store your clusters. Okay. So I applied that policy before, so I'll go ahead and take a look. I'm just looking at the policy fix. And we can see that's non-compliant because if you recall, I had it set to inform to tell me if the config map was configured as I expect. So when I look at the YAML, I can check the status, and we can see that cluster 2 is non-compliant. That's not a lot of information, right? It just tells me what I was. So the policy framework, the policy out of that policy, and what I mean by that is that on the hub, there's a namespace for every single managed cluster I'm mentioning for that hub. So we have cluster 1 and cluster 2. So if you recall, before we only targeted the Boston data center cluster, which is cluster 2. So I can go and look at the policy in the cluster 2 namespace. And this one, so the cluster 2 is reported back saying that it's non-compliant. And why it's non-compliant is that the big map called dev.demo default namespace is missing. So what we can do then is use that to enforce so that the policy actually. So the big map will actually get created. So again, I have the remediation action set to inform. So enforce. So it's fine now. So what I can do then is I can go to cluster 2 and get my big map here, and exactly as I specified in my policy. Do the same thing on cluster 1. You'll see that's not there because I only targeted cluster 2. Now, say I wanted to target all my managed clusters, what I could do is I could edit the placement that I talked about before. And if I scroll down, you see the label select Boston. You can go ahead and delete that based on how you go filter in the column. And then watch the policies again. So it's non-compliant now because cluster 1 did not have it. And now it's compliant, so we can go back. I can see that now cluster 1 it also has it. So I'm going to go ahead and clean up that policy. So now that we went through one demo, I just want to give a high level of architecture to summarize kind of what we've seen. So we defined a root policy, what we call it policy is that policy namespace. And then a copy was made of each policy into the managed cluster on the hub. And that's specific to that managed cluster. And then on the managed cluster side, those policies are pulled down. And that allows you to process those policies on the managed cluster, and it can be disconnected from the hub, like disconnected environments. But then when it is connected to the hub, it'll then sync back that status over to the hub. So that way you have all that status information on the hub. And then additionally, there's policy controllers, which are the actual controllers that will enforce or inform the configuration policy. There are a couple other different controllers that you do have, but it's also, we're working on making a library so that it's very easy for you to write your own custom controller, do whatever you want. One example is like if you want to do like an scan on all of the services within your cluster to find out the TLS versions that they are reporting, because for like FIPS compliant certain TLS versions. So the next demo, I'm going to talk about policy templating. So it's a feature within policies. It allows dynamic configuration policy definitions. So what I mean by that is that if you have the same piece of configuration that you want to apply to multiple clusters, but one small piece of that configuration is different per cluster, you don't want to have to duplicate your policies for every cluster. So it allows you to use dynamic values, replacing dynamic values by querying the value of that value. So there's two ways where this can happen. So on the hub, so as you know, notice with the limiters or the hub, that policy template gets executed before the policy makes its way to the managed cluster. And then similarly, there's just the managed cluster templates, which is double curly brace, and those get executed every time the policy is evaluated on the managed cluster. So some examples here is we have from config map template function, so we're grabbing a field from the config map, and we're using that value instead of just some static value. And then on the second example, we're actually getting a field from a secret on the hub, and using that value. And I'll talk about some of the security that we added that's kind of baked in behind the scenes for that function demo. And then lastly, just to show that you're not limited to whatever special template function that we have in specific domain resources, you can just do a generic lookup. And the last example is getting like metrics or a service called metrics and just getting that cluster IP. So the next demo, I'm just going to be showing you really copying the secret value from the hub to all managed clusters. That value is going to be different for the managed cluster. Just apply that second example, and I'll just walk you through it quickly. So I first created a secret called DevConf demo source secret in the same namespace as my policy. And this is important because hub templates are restricted so that you can only query for objects and Kubernetes that you have the same namespace as the policy. This is to prevent anyone who does have write access to create policies in the namespace from them being able to privilege escalate and grab any resources outside of the namespace. So there's that limitation for that. So I have two fields in that secret. I have cluster1 app password and cluster2 app password. So as you might guess, I'm basically going to be creating a secret on each cluster with an application password, and the value is going to be different per cluster. So I have policy, demo secret. I have a configuration policy that was saying that we are enforcing that we must have a secret called DevConf demo. And here's the template here where I'm doing on the hub side. So before the policy gets distributed to the managed cluster, getting from secret, same namespace as the policy. We're getting a secret DevConf demo source secret. And then the field is dynamic, where I'm just taking this managed cluster name dash app password. That's what this is doing. So cluster1 dash app password, cluster2 dash app password. and we're just applying it to all clusters. So now on the hub, let's take a look at our policies. And we can see that. So if I go to starts with 8, and I do that same. We can see that we're getting the value for custom 2 that we wanted. So we're able to do that by defining just a single policy. And some of the security aspects that's going on behind the scenes is that, again, if we look at the copy for cluster 1, for instance, of that policy, we look at the YAML, the value for app password before it gets sent over to the managed cluster to be applied is actually encrypted. So we like decode that base64. We can see that's just gibberish, it's binary data. So what's happening behind the scenes is that each managed cluster has its own unique encryption key. And the hub has access to that encryption key, so it'll encrypt that data before it inserts it in the policy. Policy gets moved over to the managed cluster, and then the managed cluster is able to encrypt that in memory and apply the secret that. So this is kind of a lot of YAML. Definitely to write a policy. There's kind of stuff that's wrapped within stuff. So one way to simplify this real quick is that there's a tool called the policy generator, which is a customized generator plugin. It's especially useful in GitOps environments because I can execute customized. So for instance, open cluster management has its own concept of GitOps. There's an application add-on or you can use ROCD. And there's a really helpful Red Hat blog on how to use that. But real quick, I'm just going to show you for our first example that we have, that I showed you, that first demo where we're having a policy with a big map. I just have a customized YAML where I'm specifying a generator that I want to use. So customize the generator plugin, just a plugin that will generate YAML content applied to the API. And you can further customizations will customize with that afterwards. So my policy generator.yaml file is just this. It's basically, this is boilerplate to identify that what plugin you want to use to customize. So it's not really important to what we're trying to accomplish. But here I'm saying my policy should be in the policy's namespace, and I want it to apply to the data center Boston. And I have one policy that I want. Called devconf demo config map. I want to enforce it, and then my manifest that I want to wrap in my configuration policy. I can specify a directory or a single YAML file. So in this case, I'm going to specify this config map.yaml, which is the same one that I had in the first example. So if I go ahead and run that, so I just ran customize build in that directory. And you can see it generated that placement, so that allows me to have my policy just sent to my Boston clusters, placement binding, and then the policy itself, and you can see that configuration policy wraps this config map. So it's so all you have to do really in a GitOps scenario, if you have the policy generator installed, it's really just committing those files I just showed you, and then at execution time, when GitOps tool will run customize and generate those policies. Yeah, so some coming improvements. So the first one is a disclaimer, unfortunately, is that with the new open cluster management release, there's a helper tool in the community called Cluster ADM that makes it easy to install and register your clusters and such. There's an issue with the latest release, so it's being fixed next week. But we're working on improving documentation. A new feature that's coming is selective policy enforcement. And what that means is that you want to have a single policy that you enforce on some clusters but inform on others. So if you want to roll out a change, for instance, on select clusters, just to see how things go before you apply it to all your clusters, that's a mechanism to do that. So that was want to make integration with Inferno quicker, and then also document how to install a single cluster without the rest of the cluster management. It would be an easier process, I think, for people who are starting out with one cluster, getting another with policy, and then as they grow their environment, they can use it in a So we'd love for you to partake in the community. We have a website here that shows how to get started, how to install cluster management on your clusters, how to install the policy add-on. Talked about you contributing to GitHub. We have a Slack channel. It's linked there. We have community meetings once a week, once every week. So please, please join if you're interested. We'll help you out get started. If you have questions, and so now I'll open it up for Q&A.
Any questions? Can you come over to Mike?
Hey, so you showed an example where you queried your hub cluster to show which of the managed clusters were compliant or non-compliant. Let's say you were an administrator of a hub cluster and you wanted to proactively be made aware of clusters you say non-compliant. Is there a mechanism that allows you to do that?
Yeah. So there's currently a mechanism right now that with another add-on for observability, you can get alerts based on certain metrics that happen. So you can get alerted on when a policy becomes non-compliant. Alternatively, there's Ansible integration as well. So anytime your policy becomes non-compliant, you can execute your Ansible job on Ansible Tower. So that's another way if you want to have it through like ServiceNow tickets or something like that. So a couple options there.
Thank you.
Any other questions? All right, thank you.
Yeah, okay. Yeah. Get an invitation on
So you joined? You probably not. So I don't know what you I went from no. Yeah, what you said on the Crazy stuff. My car's broken. Okay. Not as much as they should. No, they basically like they do single hire. They like hire. They seem opposite. They're 80 now. Well, maybe 17. They don't have. We got awesome. Or we pay team to do minor places. I think we got great. Pretty.
Yeah, that was the, yeah. Oh, it's back in, actually. Yeah.
it's 3 o'clock, so normally it's 3 o'clock, it's not that 3.
Yeah.
But I like to be like set up, prepared.
So, I would put aside 10 minutes, 4 minutes,
Okay.
and then 5 minutes.
Normally this talk, I have time. So I should have some time for Q&A afterwards,
All right.
which is in my opinion. The problem is that I have Mac, but I have my phone is from Europe, so basically I need to find the right one.
I have an adapter.
Oh, it's no worries. I just need to find the way that because it's super heavy, it's always possible, so I need to find the right balance. Well,
Good.
the lights is up, everything works. This is the screen.
So you have white slides?
I always have white.
Okay.
Yeah.
So on the live stream, I think those are the slides, white, you would, so
I move a lot, so sandbox. But in general, I thought I move a lot, so just be
So I'll just go back to you with the slides in that I provided.
okay. No worries.
And then if somebody starts asking questions, you can let them ask questions all the way through, we can start doing it.
Depends how many people. If there are not that many people, then they can interrupt me. If there are many people, it's better.
Okay, so if you do it at the end, we'll just get to it. We're just going to do it in the middle.
I will just take the questions. No worries.
You've done this before, right?
Have it. Let's say a bit.
Do you need anything else? You good?
Nothing you can help me with. Thanks.
Bless you.
Thanks. Do I need to do something? Is there stuff? Thanks.
No, I'm just going to set this in case you wander around, and I'm not going to worry about the screen on here because you cannot see a thing.
really visible.
Well, the good thing is on the stream you can see it very clearly when I go to the slides.
Yeah, I hope there won't be too many people because if you stand, I mean, I wouldn't be able to stand in the back and see anything, even with my glasses probably. Okay, thanks.
No worries.
for coming back.
Good luck.
If only
they got you doing everything, right?
I know.
You know,
How you doing, man?
not too bad.
You having fun?
It's good.
Yeah.
What about you?
No, it's good. I enjoy it. This kind of stuff is.
Hey, are you looking for me?
No, I don't know for whom, but so there was a session like right before here.
Yeah.
And apparently somebody got the feedback through the feed. I don't know if the mic there is open, but apparently something picks up the sound from here, and that actually goes louder than the people talking there. I was really surprised how this
Maybe
was the
that
case.
mic
Maybe
is
that
on?
mic.
No, this was up there before.
Okay. So I don't know.
So-
just providing the feedback. It's not from me. I don't know.
There was no mics up here during the last talk, so I don't know what's going on. Where was it? This may have been. They had two mics up there,
Yeah, because when the two of them were presenting, right? That's,
Yeah.
how I should.
Yeah. and that mic was on as well. So I've switched everything off, and I'll only have his on while he's talking. And
So
then
again, it wasn't me.
Do you have any way to
I'm just
monitor?
providing the info. as
No,
I
no,
got
no,
it.
no,
I
thank you.
thought- So in case you see something else, you need to go up.
Alrighty. Okay. Thank you.
Do you have the monitoring headphones or anything?
No, none at all. There's like you can see there's like a little monitor thing there when the mic goes on. I'll get to the mic.
And this one is definitely off. This head.
No, of course not. Yes.
Somebody was saying there was feedback during the last presentation. I don't know.
I have no idea
Up on mic so they can hear the booth audio, which is weird.
because there was no mic up here during the.
That's also weird.
There we go.
Why is that backwards?
Oh, wait.
I don't know. Online it's fine,
That's so strange.
but there's no mics here. I mean, this was even up there before.
Probably happens if there
But
are
what's
two
up with this one? Is this
mics
one dead
open
now?
at the same time.
Yes. Okay.
So that's, you probably forget it on when they use the other one.
Fun.
Cool. Thanks.
Whenever you want.
We're streaming all the time.
Okay. Hi, everybody. Thanks to be here. Really, thanks to be here. Like 5 people. And this sort of because that would be fun. I'm happy you are here. I'm happy you made this choice. I'm Nicola Frankel. I was a developer, blah, blah, blah. I was like super disappointed after 17 years of doing consulting because I had to choose always technical solutions to resolve organizational issues. So after that many years, I decided, hey, let's do some developer advocacy. Anyway, who here has already designed REST APIs? Okay, great. So I assume the first time you did that, you were like very focused on designing your entity, in finding the right boundaries, then finding the right types, then you had to think about the REST semantics, when to use put or post or patch or whatever. And you didn't think about stuff that was secondary, that was not really required for the project, for the successful project. So basically, when the business comes to you and say, hey, we need to deploy a V2, you might have this kind of reaction. So my idea, this talk is just to give you a couple of tricks so that the next time you design something, you might already like incorporate this kind of stuff from the ground up. So here we have the initial situation. You've got your upstream and you've got endpoints. Yeah. Okay. Then you fell into my trap. Probably you lied. Because my solution is, hey, just put an API gateway in front and it will solve all your problems. Thanks, that's the end of the talk. No, of course not. So first, probably you lied because you wanted to please the speaker, and actually, probably this is your situation. You probably never exposed directly your backend, your upstream, you probably have a reverse proxy. And my solution is to have an API gateway, and that looks like pretty similar. So since we have some time, first let me explain to you what I feel is the difference between a reverse proxy and API gateway. So I wouldn't say all, but let's say I've experienced. So I like to tell stories, and this story is the following. I started to use the internet already like more than 20 years ago, and I created my own website. And I mean, at the time, there was no, hey, build your website in 5-minute books. Tutorials were hard to come by. So basically, when you wanted to build an HTML page, what you did was you looked at the source of other HTML pages, and you had to understand how it worked. And so at the time, it was already nice because we already had images, which was not the case a couple of years before. We had audio files, MIDI files. So it was like super geeky to put a MIDI file that played automatically when people started to browse your website. That was very poor user experience, obviously, but it was super geeky, so everybody did it. No CSS, so in order to create like a bevel, because at the time it was like super cool to have like a bevel effect on the button, we used tables, because hey, that's what we had. And well, no JavaScript at the time. I don't know whether it's a benefit, but we can argue about that. But anyway, and I used this like super nice software called Hotdog Pro. Who knows about Hotdog Pro? The height of user experience, right? So I don't know about you, but my version, you could like click and it inserted a tag. There was no WYSIWYG that can bring whatever afterwards, but Hotdog Pro, it just allowed you to insert the tags by clicking a button. And of course, you had to click the button to close the tag. It was really, really cool. But still, it was great to learn. And at the time, I didn't give it too much attention, but basically, I just put the files in the folder and the files in the server, and the web server served static content. And it worked, and I was super happy. And then some people decided that was not enough, because actually we couldn't display the date and the time. That was really a huge issue, right? I mean, it was not enough that the computer gave you the date and the time, but we couldn't put it into the web page. So that was also completely useless, but that was super geeky. And so people decided, hey, instead of like writing the HTML, let's have a script generate the HTML. And in that case, it was CGI script, so you had to learn Perl. I didn't learn Perl. And a lot of people say that that's not super great to have to learn another language. And even if you knew already Perl, the problem is basically it was like not super maintainable, because you had to understand what the script did, what the generated HTML was. So the improvement was to write HTML and just to have like tags inside, and then you had PHP. PHP was much better. PHP, which means personal web page, yeah. Like they try to hack it, saying, hey, it's PHP is a hypertext preprocessor. Actually, it's personal homepage. It doesn't look super professional, so yeah, they had to come up with a better name. But anyway, today it's super successful. Then the internet, and especially the World Wide Web, became more and more ubiquitous. And like companies, not only geeks, but real companies with more money. Like if you are a private company and you like into the web server, so we had actually the real like layer. And when you do load balancing, basically all the nodes are equal, all the node sides. Perhaps you have different lines or whatever. And so you needed to serve different content. Like first layer had to do routing depending on the request. So the evolution of the web server went through several stages. Like first you serve static content, then you serve dynamic content, then do stuff that is completely unrelated to serving content, like load balancing and routing. And because of this, there were some people who started to think, hey, like now we have a single point of entry into the information system, we can probably do much more. Authentication, authorization, caching, ID blocking, rate limiting, whatever. And on the other side, because of the rise of the internet, we needed to share data across heterogeneous information system. So I assume here you have mostly people are Java developers. So you remember CORBA, you remember EGBs, everything was great. But actually the problem is it works only inside your single line Java stack. And some companies are using, I don't know, Python, .NET, whatever. So the most basic stuff at the time was if you wanted to share data with another company or even sometimes another department, what you did is you uploaded the file on a remote FTP server. Then you would have a batch that watched the server on the other side, read the data, do what it had to do, and rename the file to .dot. That was like basic level. But it works only if you don't need like close to real-time data. If you want to have HTTP endpoints, because HTTP endpoints is the most basic brick that is found across all tech stacks. So comes the definition for me of API gateway. It's a reverse proxy that can do stuff that reverse proxy were not meant to do. And generally, this stuff is focused on APIs. For example, I mentioned rate limiting. Any reverse proxy can do rate limiting. The thing is, now, you don't want to do rate limiting because you want to avoid DDoS attack. Of course, you want to do rate limiting because you want to avoid DDoS attack, but you also want to do rate limiting to, depending on the profile of the client, to say, hey, if you pay me this sum, then you can call that many calls per hour, and if you pay higher, you have a higher limit. And this is business logic. And in that case, the API gateway is a way to integrate business logic into your reverse proxy, into your entry point. Billing, the same stuff. You might want to log like requests. A normal reverse proxy can log requests. But if you want to do billing, you must be sure that the log is actually on point, that you don't lose that. And so perhaps you want to talk to Kafka or whatever, but you want something more. And for all those reasons, like the API gateway for me is like the next generation of reverse proxy. There are a lot of API gateways available on the market. Probably you know some, even perhaps most of them. I work on the Apache API 6 project, so I will have a couple of slides on it. My demo will be using it, but of course you can use any API gateway for the rest of the talk. So Apache API 6 in Apache project, it's like managed by the Apache Foundation. You can become a contributor with like a layer of OpenResty. Basically, OpenResty allows you to write Lua on top of Nginx to manage and to have some like intelligent routing. So you can use Lua scripting. So coming back, now that I have defined what for me is an API gateway, you can solve all your problems by introducing an API gateway. I talked a lot, and now let's do some demo. And I'm sorry if you're in the back, because the screens are pretty small, so I will try to make the font bigger. Is it good enough? Perfect, thanks. I'm happy there are young people, because if I would sit in the back, I wouldn't be able to see. So my idea is, yeah, you have glasses, but me as well, but it doesn't work that well anyway. API is a Spring Boot project, and here it's written in Java, and there are tons of annotation. It doesn't open, that's really good. No, just takes ages.
So yeah, I have to endpoint hello and hello with a parameter. And my idea is, hey, I want to rewrite everything and to do much better. And I want to write everything in Kotlin using like declarative endpoint. Obviously, the version is much better. Everybody can agree. So now I have the deployments. I will be using Docker Compose because it's good enough just for the demo. So first, I want to like deploy API 6. API 6 depends on etcd because it stores its configuration in etcd. etcd is a Kubernetes store that you use both, so it's pretty solid. I will show you the API 6 dashboard. I want to monitor everything, so I have also like deployed Prometheus and Grafana, and finally I have deployed the old API and the new API at the same time. It's just because I'm super lazy, I want to deploy everything at the same time. But of course, normally you first deploy the old API and then afterwards the new API. So let's start everything. I will just try to remove everything just to be sure. And now we can start. So let's wait a couple of seconds, especially since we do too long. It should be started. So let's see if it works. I will curl hello and defconf. Yes, it works. And the second version is deployed in another port. And it's much better. And now the idea is I want to go through the API gateway. So normally you shouldn't be able to access by those ports directly. You just need to go through the API gateway. So I will do this. And obviously it doesn't work. The reason is I didn't configure anything. I just started the stuff, so I need to configure. Configuration in Apache API 6 is quite easy. It can be managed through an API call itself. So here I have the scripts. Since everything runs on Docker Compose, and I don't want you to need to install curl because everything is on GitHub, so you can do it at home. You just would need Docker. I am also using a Docker image, the curl image actually. Here is just to use the same network because I have Docker Compose, which is a separate file, so it has its own network. Sorry. And then I have like the Apache API 6 endpoint, which is the routes. I create the ID with 1 because it's a pretty sensitive operation. I need to pass an API key. Here I'm using the default one, which of course you shouldn't do, but hey, it's a demo. And now I have the payload. So name is just like optional, but here is if a request match this method and this URI. Here I have a single node, but normally you probably would have a cluster of like similar nodes, so you can have different algorithm to dispatch them between. And here, for example, it's from Robin with weight 1, or you would have multiple nodes with different weights. And here I'm saying login details just to monitor it. So I run it, and now if I configure, so now I'm going through the API gateway to go through the old API. Perfect. Which means I'm back to square one. I didn't improve anything at the moment. Just like made this thing working. Next step is a bit more interesting. I want to deploy several versions. Query parameter, a header, whatever. Here on the first route, I created everything in one node. But actually, there is an abstraction that we might want to reach, which is the upstream route. So first, I will create the upstream, and then I will be able to use it in different routes. So first, I create the upstream, and then I will create the plugin configuration. And finally, I will create the version route, and in here, I will be using the upstream ID that I previously created and the plugin configuration that I previously created. So let's run this. And now there is a little trick. And the little trick is the following. Now I will expect to have v1 hello. The thing is, if I do like previously, then I will forward v1 hello to the upstream. And v1 hello, the upstream doesn't know it. It just knows about hello. So I say, like, I will receive something like this, and just like use what is after V1. So this gives the following. Now I have two routes. If you are not a fan of the command line, we also have the dashboard, as I mentioned. Now I think it's 9,000. Yep. I let you guess what the default password is. Of course, it's a demo. You shouldn't use it. And here we can see our two routes. So if you prefer to configure it to create a new route through the dashboard, it's possible. Here you can see that directly. We can see the JSON configuration, and we can change it, like say, hey, like directly. Then it's instantly like saved in etcd, and we can see the upstream that we created before. So depending what your approach is, you might want to favor the API or API. Okay, great. Next, version route that we want people to use, and we have an unversion route that is asking people to register. Like the first time somebody used your API, you were super happy. So there is no way to send people an email saying, hey, please, we will deprecate this endpoint and blah, blah, blah. So let's use HTTP for that. So what we are doing now is the unversion route. We will send a 301 and a new location, and the new location will be first the version route. That's easy, actually. Again, we have a plugin for that. And the plugin in that case is a redirect plugin. So basically, if people are using the first route, so here I'm using the patch, and just changing the plugin config, I will say, please use the same rewrite that you tried, but prefixed with V1. So that it works also with DevConf. I forgot to send it, so I need to do this. Okay, and now we have this like move permanently. If we look at the header, it sends the right location. Now on the client side, there are two options. So first, even if you are not an API provider, please always monitor your API calls on the client side. Please, please. Because there are two options in that case. Either you are like getting this 301, basically nothing works anymore, and you need to know it before your business knows it. Or you can also do automated redirects. In this case, it will still work, but you will make twice the number of requests. First request, you will return the 301. You will do a second request with the new endpoint. So your infrastructure will probably consume more resources. Okay, not bad. Now we can do a bit better. The problem that I told you about is we need to use an HTTP code because we didn't think about making our user register. But it's normal. Who here likes to register? You love to give out your email, so that you're kidding. That's good. Yeah, I think nobody here loves to receive like spam from marketers, especially when they are not super relevant. But I assume that most of us like sword benefits, free stuff. So in that case, you can be smart. You can say, okay, we limit you by default, but if you register, you will have a higher limit or an unlimited number of calls or whatever. So that's a good stuff. Again, we still don't know our users, so we need to like return a code and give the message asking people to register. At this point, unfortunately, there is no plugin out of the box that does it. So what I did is I created my own plugin, and it's called unknown limits, and basically it's written in Lua. Am I a Lua developer? Not at all. What I did is what every developer does. I copy-pasted the limit connections. There is a plugin that does that limits the number of calls, and I just added the logic that I wanted, and basically the logic is, hey, if I'm authenticated using this plugin called key auth, then just return. Otherwise, continue to do the logic of the limitation. Is anybody interested in Lua code? Oh, that's what I thought. That's pretty solid, and that's good because I wouldn't be able to explain too much because I did it and it works, so I forgot everything. The idea is you can configure it like this. Here is the number of calls in this time window. So if you go above this limit, then you will get this code and you will get this message. So let's run it. And I need to do one again because it's on the second round. Now I'm limited. Don't try to register, it's just a dummy message. The registration system itself is outside the scope of this, so whatever you want. In the end, you should have people register. So here, I will register a stupid dummy user in the simplest way possible, and basically it's through a key. So basically here, I can create what we call in API 6 consumer, and this consumer, its username is Jandu, and how do you know it's Jandu? It's Jandu because it has a header named API key with value 9 key. If I have this header with this value, I will be considered Jandu, and because I'm considered Jandu, I will be authenticated, and because I will be authenticated, I won't be limited. So let's create this user. We can check here that now we have the consumer that is created, Jandu. And now I need to pass the header, and it's API key, my key, yes, super original. And it works. I see you frowning. What? That's not clear.
It's just your key is key.
Yeah, here I could replace. I could also replace the key.
The other side, I mean, about that.
I don't understand the problem. Sorry.
That's a
Okay. Is it here on online? No.
no,
Oh, okay. Come after me. Come afterwards, and I will try to understand. Okay. It's good. So the next step, now we have everything, is test. So who does unit testing? I don't want to delve too deep. Okay, great. Who does integration testing? Good. Who tests in production? Yeah, everybody does test in production in the end, so at least you are very, very open about it. In general, you test in production by doing canary release. But I would encourage you, before doing canary release, to just mirror the traffic and to send it to the new endpoint. And you discard the response, and just to check that your code works with real production workflow. Because whatever your tests are, however great they are, there is a high chance that in production there is something that happens that you never accounted for. And if it runs, if you receive it, you might get a null pointer. So before doing canary release, you might want to do this mirroring. And in API 6, it's called like mirror traffic. So I will get all the loads and I will send it to the new endpoint. And just to like manage your expectation, at this point, there is a bug that will be fixed in the new release. Now the bug fix has been done, it just needs to be incorporated. Let's do a couple of calls. And let's look at the dashboard. So here is the Grafana dashboard for API 6. What I did is I just added 2 new widgets. It's a bit small, I'm sorry. But the idea is here we monitored everything with Prometheus. So here we already have some data. And normally after some, yes, here we start having some data as well. So normally you should have the 2 curves, and the curves should be similar. If the curve on the right is not similar to the curve on the left, then you probably have issues. So here I have issues, and the reason is the priority. You didn't want me to show you the code, and I agreed. There is something you should know, is every plugin has a priority. That's how API 6 knows the order in which it should apply the plugins. It makes sense. Well, before I said there is an issue, to the V2 is V1 something. And again, it should be only something. In that case, hello. So now in the next version, you will be able to override the priority on each plugin, which will probably solve the problem. And so now we have 4, of course. It's logical. And so now let's do finally, some canary release. So you can release based on a header, you can do canary release based on geolocation, you can do canary release based on like just randomly. Here what I did for demo purposes, I do random stuff. Basically, half the request sends to the old one. So I have here, and now I can show yep. So normally it should hit the new version half of the time. Of course, it shouldn't be at the beginning. It shouldn't be 50-50. As I mentioned, you could like restrict it to a limited number of users, like perhaps 10% or 5% or 2% if you are conservative, depending on how many users do you have. But basically, that's the idea. Great. And what's the last step? Well, the last step is now you have a V1 and a V2. And probably at some point you will have a V3 and a V4 and whatever. And hey, what is the issue? Yeah, sure.
So back in the cameras.
Yeah.
Is there to do it for certain names?
Is there a capability to do it for?
A certain name. So we just do some tests and say, okay, these users, I want to check it out. I'm a limited audience that will check something out. If they're good with it, we'll flip the flag.
So the question, is it possible to restrict it to a number of users? I don't know if you can restrict it to certain consumers. I know that you can restrict it to certain headers. So basically, you could have a dedicated header with a dedicated value. I need to check the documentation if for the consumer itself, but for sure for headers you can do it. So it would be similar to solve the same issue. So now we have like multiple versions in parallel. If you're a product manager, you know it's not a great idea because that means that you need to you have a limited budget and you need to maintain all those parallel versions. So you probably will want to deprecate some endpoints or even to remove them. And we do it with HTML? No, but there is an ITF draft that tells about deprecating endpoints, and it's called the deprecating ITF draft. So basically, you have a header, and this header is called deprecation. In the demo, it can be a Boolean or date. In the demo, I'm using a Boolean. I would really encourage you to use a date, because you probably want to warn your user in advance and not just say false, it's true. But I'm lazy, so I'm using a Boolean. And then you have another header, and that points to the endpoint that you should use, that your client should use. And also there is an optional header that's called sunset, and then you tell at this date holds no endpoint at all. So it's just like in Java API, first you deprecate, and if you are in the old Java version, you keep it deprecated for ages, and at some point, finally, you remove the API. So it's just the same. Actually, it's quite easy. We can add headers. So first, I will create the routes, and then I can duplicate the view1 route. And here is just about adding some headers. So that anything, it can be, as I mentioned, a Boolean. And here I'm using some Nginx variable, so I don't need to write everything again. So here, then when I curl with the view1, and I want it to be verbose, so you can see. So here you can see it's deprecated, and the link points to the version to use. Now, normally, again, because you are monitoring your calls, then you can call the issue. Now, every time I at this point, you have finally migrated your APIs. Okay. Last step. Enjoy. I believe that at this step, if you have applied all the previous steps, well, thanks for your attention. You can read my blog, follow me on Twitter if you're interested about the code. Don't come to me afterwards, you can check it on GitHub. And of course, if I got you interested in Apache APIs, feel free to have a look. And now we have like a couple of minutes, more than a couple of minutes for questions. So I will be very happy to try to answer them. There is a mic, so feel free to come. Or perhaps I will bring you the mic because, yeah, even better.
So is the performance good enough to transform the requests and responses from the V1 format to potentially a V2 format if the REST structure is different?
You know the answer to that. It depends. It depends on the requirements. It depends on the complexity of the transformation. I mean, as I mentioned, I was a consultant for a long time, so the question is super generic. I will need to have more requirements, more constraints to properly answer. But I mean, as an educated guess, what I would advise you is not to do it automatically unless you really, really want not to break anything. So if the requirement is not to break anything, then you will need to pay the costs anyway. If you are allowed to break, then probably like a proper route to handle the same would be better. So as I mentioned, first tier one, tell your customer, hey, please use it. Then after they are registered, you should have their email. So you can contact them directly and tell them, hey, dear customer, dear client, you are using this endpoint. We are probably removing it. Here is the new documentation, blah, blah, blah.
So we have very long deprecation cycles in OpenShift engineering. So like I was trying to work out if it's better to do transformations in an API server and then deal with one version of the code itself. But I realize it depends questions.
Yeah, the life cycle is not an issue. The issue is whether you accept to break things or not. And then you answer. Then whatever the performance cost will be, then you will need to pay it anyway.
The other option is maintaining it in the backend code of the customer. So it's sure.
That it's a product management decision.
I was more concerned questioning if you said don't do that. It's a stupid idea. It sounds like
No. To be honest, again, I've been a consultant. I've seen a lot of stupid stuff. So now for me, it's part of life. But no, you can transform. I mean, if your requirement is not break anything, very conservative, we want to keep our customers, every one of them, please do it. Then, of course, monitor, check that the cost is not too much, and if it's too much, then you know the answer. But I mean, in general, my approach to many things is like trial and error. Try, monitor, check, and then check act. Nothing mind-blowing. Other questions? Thanks. There is a question.
Sorry, I was just wondering if there are any HTTP libraries that automatically detect when there's a deprecation header and warns in the logs. I'm thinking as a consumer of an API, unless I know that header is there, I wouldn't know when it actually is going to be there.
That's a good question. So first, my first question to you is, a library in which language? No, I mean, checking for the existence of the header, if you use Quarkus or Spring Boot or whatever, should be pretty easy. So I don't think there is such a thing. But perhaps it's a good idea to create such a library and to redirect yourself client side saying, hey, if I see this header, I will check for the link and I will do that. It's possible. But to the extent of my knowledge, no, I know nothing of the sort. Actually, it's a draft, so basically, people are not super eager to build something on the draft. Other questions? Thanks. Then I thank you a lot for your attention, and I wish you a good rest of the conference. And I have stickers and lapel pins if you want. That's
we have a couple of like there is one, two, three, on stickers, please. Nice to meet you. Oh, really? Thanks. Thanks a lot. Appreciate that. Thanks a lot. Yeah, sure. My question on the by the way, if I answer was confused because you had my thing. Yeah, yeah, Mark noted that you used this. Yeah, the name of it is NTA. The name of the header is NTA. It's not. And the English is not good. Yes, but you can override it. So here, this is plugins. You can take both. Now, here. Authentication. So you have all the stuff by default. Check into it. Yeah, I like it. And here I'm using the API, which lets you like choose configuration for robust stuff. You can like write it in a public configuration in YAML. Then you can add like TikToks. So everything. Yeah. So here it is not okay. I want it to be like integrated. Even this is for fun, but for like more robust production, not production. And if your stuff doesn't change that often, then you can have this kind of like standard report. Another question,
if you're rewriting the header, or you're rewriting the head, so those such
You can run, you can rewrite the header, you can rewrite the request. For example, in Spring Boot, when you use like this on the front end, you have a specific flag that allows you that the framework itself will understand where you come from and like contact the client's response. So I guess there's no focus that was the same. That's it. The thing is, again, I cannot answer for you, because the issue in that case is what you guys say. You know, I know it's like a couple of years ago, I took on like DevOps on Spring Boot, and I explained how to monitor the endpoints, the AHA, and I had a lot of questions like, hey, what's the performances? And like stupid answer that. Okay, so imagine you are driving a car. We better to drive super fast without seeing anything, or a bit slower and have good view. I mean, unless it's really a big issue and it's easy to get people because all the comments can do it but visibility and efficiency. But to have the exact numbers, you need to do that. Sorry.
Yeah, it's fun to check when you were creating and configuring the gateway.
Yeah.
Is that the endpoint part of the gateway? We have the, I mean, on the gateway itself, or
Yes.
do you have a function plane that is independently managing that?
So about the data plane, the control plane, we are working. There are different architectures, and we are trying to get now that it's separated as much as possible. But
But
here,
it's embedded in the same gateway.
sorry, yeah.
It's embedded in the same gateway.
Yeah, it's the same endpoint. So basically. But here, again, we are working on that.
And the other question is, we have been struggling a lot with nobody for us to do.
I do. No, honestly, I don't know. But actually, I mean, I don't know about you, but I have a couple of years of experience, and I'm not a Python developer, but I want to do something in Python because well, it's very mechanical. Okay, they probably won't write the best Python ever, but it works, and it's mechanical and it's readable. So I asked, I write a code, and I asked a Python developer, hey, is it the Python way? Say yes, no, and it's words. And with UI, it's the same stuff. Like, I don't know how to do that in UI. So I write, hey, how to do it in UI? Because I know in my head what I want to do. I just like the word. So when I know the words, then it's great. But there's more plugin than the word. Here you have like all the plugins out of the box plugins. So you've got maybe
So you have more extension.
yes, but so here I wanted to write like in Java because I'm a Java developer and stay involved in Java project runner and honest. Yeah, so right now we have a person working on it. So I'm trying to improve it. At the moment it's not great. Like there's usually you have code-based templates project and write your stuff in it. How does it work? You have multiple plugins there, you write it. They cannot. My colleague will talk on it. They don't want to do this. I think it's I need to check one of my next proposals will be about using Rust. How to install and use Rust, compile Rust, Rust, and you have Rust and run. And I think it seems to be much. Yeah. yeah, more integration. So normally everything that is on the right should run, but at the moment, I did like Lua is like nicely synchronized. So yeah, that's actually that's the open REST layer. So the open REST is like an additional layer on top of Nginx. So basically, the problem Nginx was designed at the time of the source. And so basically, every time you change the configuration, you stop, which is unfair. And so the idea of REST is you can change the configuration by script. And so you can script freely, but here is an additional sort of already have some points. So this is again an additional layer that is bootstrapped. Yes. And if you have no question, then my name is on okay. Okay.
Yeah, and you can add this to your list of techniques. I know.
Hey, I didn't say for you. I talked about my competitors already.
That's great.
I
mean,
not
that
everybody
I
knows
know
it.
it's great. So you already doing that from good. Good confirm
Like this.
No, that's really like the number and scale.
I don't know what to say. Okay. Very red. It's the first time I hear about this. Oh, really? Yeah. I entered the field like 6 months ago, so I'm not an expert, obviously. I asked my lead stage should we like watch, and I answered. Yeah.
It's gonna be so. Yeah. Good person. Ambassador, all of these.
Yeah. Yeah, the thing is, 6 months ago, I interviewed for them, so I know them. They are much more like focused on like user experience, so they have nice dashboard and everything. And the HTTPS is also is Express, and we are implementing also gateway. Yeah, we are implementing. So it is very
So you're doing something similar now with another company.
So I didn't play with it again. I don't know how good it is or not. And obviously I know it's going to production, but I think that's my issue. You can check probably like this.
Yeah. Oh, awesome. So, yeah, in terms of even here, all your countries.
Okay, I hope you like it.
Here, states, so great. How we go the rest of the
Competitors actually,
no, it's like, there's things that from all the like that voice calming,
yeah.
beyond the problem. Because you can't from one place to another, Like you go to conference.
Sorry?
Have you go to conference?
I arrived. So I had to wait at 4 o'clock. I got from the weekend. I was at the conference.
Oh.
I arrived just like on the Sunday and told to go like this. Yeah, I arrived on but yeah, it's pretty hard. So I will probably visit. It's my first time in Boston, so it's a conference, and it's a thing as a tourist. Well, I shouldn't say, but there will probably like the tourists.
We did there, yeah, it's more. So it's a nice city, it's very storytelling. One of the most historical cities.
And on Sunday I fly back.
Okay, enjoy the city.
Thanks a lot.
Take care.
You too, bye. Thanks. Just in time.
Well, I think for that is not.
Yeah, sorry.
No, it's okay.
What time
Oh,
should
there
we
you
start?
go. All right, no, there's
What time should we start?
4 minutes.
Oh, fuck, sorry. It's not good. Myself, I made that. Yeah.
Funny that I had exactly the same thought about. Should we put you on the service so you don't worry about it? But then it's like, it's with that one flight. One flight and then we. Yeah, but we have such a terrible. The deprecations are so long. We're not even allowed to deprecate.
Yeah, but you don't have the same, I mean, you have not the same user base as.
Right, no, absolutely. It's not a bad thing.
If you have web scale, of course, like half a percent of your users might be like 5,000 people. So it's,
Well,
I can understand.
and if I'm doing a website, like, the job is.
Yeah.
Where am I writing now? The timeline is different. I realize we're going to use this.
Yeah,
It was
you-
more of a theoretical question. It seems like a good idea to do this principle, but the practice.
Yeah.
But honestly, what we really want to do is serve all transform calls and we do all this stuff and then we call it common library. Do you work for Texas?
Well, yes, it's an initial project, so no, I work for one of the companies that contributes standards, but I don't contribute this. Well, I contribute what's one percent. I'm not a committee.
Yeah, it's not. So much for documents. Socializing and communicating.
Yeah, but sometimes I can answer questions. I mean, with age, I'm more comfortable with that, but it still feels a little to say, hey, I don't know.
I think saying that is.
It's a sign of maturity.
Exactly.
And for you, super major.
You have a tough time slot competing against the lightning bugs.
Unfortunately, yes.
And we wanted to go home, so bad, unlucky.
Can you say something?
Testing.
It's okay-ish. Maybe put it a little bit closer, put it higher up.
Okay.
That sounds better.
It's over here.
It's very sensitive with putting too, so if you're gonna look at that screen, I'm gonna put it on that.
That is an excellent. All right, testing. Oh. Oops. All right. Yeah. Testing.
Thank you. Thanks for doing that.
think we're at time, so let's go ahead and start. All right, hi, I'm Matt Young. I have been at Red Hat for the last 8 years, been working on Podman for the last 5 of those. And today I'm here to talk about Metcalf and Aardvark, which is the new networking solution that Podman developed. I'm going to be talking about what they are, why we wrote them, and how we wrote them. So, without further ado, on. And this talk sort of assumed a bit of knowledge about Podman, containers in general, and networking in general, but not about how container networking specifically works. So let's go a bit into that. So we're going to go over specifically root networking on single nodes. Rootless is a bit more complex, and we didn't really change it at all as part of our recent changes to Metcalf and Aardvark. And also on top of that, cluster networking is generally going to be similar to what I'm going to describe, but with a bit more SDN on the top to share traffic between nodes. So let's talk about network specifically. A network is a construct of your container engine, your Podman, Kubernetes, and it doesn't really directly correspond to a kernel primitive. It's more collection primitives, but it gives a way for containers to talk to each other and to talk to the internet. And the network is composed of a few core things. The first of those is a bridge. A bridge is a virtual address, basically. It has an interface plugged into the host. It has an IP address and subnet associated with it. And the interface plugged into the host is going to be set as the default gateway for all traffic in the network. So that is how anyone wants to get out. Next. Then we have what are called VEF pairs. VEF pairs are basically a pair of virtual address interfaces connected by a cable. One end goes into the container, other end goes into the bridge. It gives the container and the bridge an ability to connect to all the other things on that network and also to the internet. Next, we have firewall units. So we've established a way for the containers to talk locally to other containers, but we're going to need a way for a container to talk to the internet. So we do that via a masquerade, a one-to-many NAT, but also we have a firewall rule for one-to-one NAT. So you want to be able to have a specific port on the host to specific ports in the container. So we've got 2 different types of NAT that can occur. And then on top of that, we need to add extra firewall rules to make sure traffic actually gets to the internet. We can't assume we're running on a clean system. People would probably add some firewall rules of their own. We want Podman to be able to access the internet even if people are doing weird firewall stuff. So, how did networking work in the first days of Podman? We used something called the CNI plugins. CNI stands for Container Networking Interface. It's a standard developed for Kubernetes to allow for a series of plugins to run in a specific order, each doing a little bit of configuration, and the end result is a container that can talk to the internet and other containers that the internet. And there is also the CNI plugins. These are a reference set of plugins for CNI that accomplish the basics. They let you get out to the internet. They let you talk to other containers. They set up all the stuff that I just talked about. So the CNI plugins are the default for Kubernetes. As such, they were the default implementation of Cryo. And Cryo was at the time of Podman's creation developed by the same team at Red Hat. So we had a lot of experience with them. We knew how to use them. We knew they worked. We knew they were in production. And we knew that they had good go-lives. All those together combined to make us think we can use these to rapidly produce Podman, get a product out the door quickly, and that was at the time what was most important to us. The plugging model, the fact that it can do all these various different things, didn't matter to us all. The reference implementation, the CNI plugins, were entirely adequate to our usage without doing any extra work. On top of that, it was compatible with Kubernetes. At the time, this was important because we were planning on sharing code between Podman and Cryo. That did not pan out, but at least for the initial days, it would do this. So, years passed and friction began to set in. Kubernetes and CNI have a model where they have a cluster, you have a bunch of different containers, a bunch of different nodes talking to each other. Podman has a single node model, where we have one node, one set of containers. And there's some friction inherent there to what we are trying to accomplish versus what CNI is trying to accomplish. And as time went on, that architectural differences were just making things different. First thing that we really noticed was Podman aims to be compatible with Docker, and as such, Docker provides DNS, so containers can resolve other containers by the name. That means we need to do it as well. CNI does not have a plugin to do that, so we're going to have to write our own. We wrote a simple implementation. It was pretty naive. It only worked for containers that were joined to the network. And it worked okay, but when we tried to submit it back upstream to the CNI team as one of the reference plugins, it was not accepted. We're going to have to maintain this out of tree. It did not work. The next issue was IPv6. CNI had support for v6, but it was complicated. It required a lot of configuration. It required the user to provide a publicly routable IPv6 subnet. What we were looking for was more of a zero configuration solution, something like what we have in IPv4, where we auto-generate a subnet and add it to the internet, something that we don't require the user to have extensive knowledge of that. And talking more about complexity, CNI has quite a bit of it. We care only about a very few CNI plugins, but there are a lot. Stuff like Flannel. And what happens when you put a Flannel network in a Podman container? Well, it should work. CNI would like to do that. But we also have Podman tools to create networks, to inspect networks. As of Podman 1.6, we added those. And we want to provide a Docker compatible interface there, as we usually do. And that means we need to inspect arbitrary CNI networks with plugins we potentially don't know about. We can't do that. We throw our hands up and we say, okay, we can't do this. We're just going to print the CNI network with a Docker compatibility. That was not an optimal solution. We didn't like it at the time. Still don't like it. The final big issue is the support situation. CNI, their job is to support Kubernetes. So when we have problems, we are largely going to have to solve them ourselves, and that's not optimal. None of the Podman maintainers are CNI experts. We grew to understand it over time, but we didn't really get a true understanding. We were not very good. And the CNI maintainers' best efforts to do it all. Their day job is support Kubernetes. If they have spare time, they can help us. But even then, our issues are complicated, and usually we're not going to be able to help. So, in the second half of 2021, things came to a head. There was a serious conflict between where CNI wants to focus on clusters with Kubernetes and where Podman wants to focus on single node. There's just too much divergence at this point. And the CNI maintainers come to us and they indicate that they are having serious discussions about deprecating our use case, deprecating single node operations. Podman needs networking to be able to. If CNI deprecates what we're doing, we need to have an alternative because we can't just say, no networking, your containers are broken. And the CNI maintainers, their positions also understand. This isn't their job to support us, and they feel like they're spending too much time on supporting. So, at the same time, we're also looking at a major rewrite of the rest of Podman's network stack, largely because of tech debt, legacy decisions. When we first wrote Podman, we made some naive assumptions. Containers are only ever going to be in one network. Containers are only ever going to have one IP address. Containers are only ever going to have one MAC address. These held for a while, but as the range of support use cases that Podman has grows, as customers use it more and more, they start asking for things that assumption is broken. So we knew we were going to have a major rewrite of our network code, especially on the database. And it seemed like an optimal opportunity to tack on some extra work in the form of replacing CNI. We also needed to address the rewrite of our DNS plugin. So the DNS plugin, as I said earlier, only works in a single network. Customers come to us, they say, I have containers connected to 2 networks, I would like to DNS on them. Okay, the new DNS plugin can't adjust the earlier one. So we need to do something. We're in a good position to commit to a lot of networking related work. What exactly are we going to do? Decision we came to is rewrite from scratch to suit our needs. We looked at all the pros, we looked at the cons. It was a hotly contested decision within the team, but eventually we decided on it. We wanted to tailor for what Podman needed specifically. No plugin model. The plugin model is wonderful for Kubernetes because you have so many different types of networks. You can't guarantee that K3S and OpenShift are going to use the same network stack and semi-competent. Podman, all our networking needs are broadly similar. The plugin model, all it does is take more time to execute, make binary size bigger. We were doing some performance tuning, and we found that on Podman Run, the single longest part is CNI setup. So there's a real opportunity here. It's the plugin model. We can get user-facing real performance benefits. Also, we can change the language. Nobody on the team liked Go. We wrote Podman in Go because of the ecosystem effect. Docker and Kubernetes chose Go way back when in 2014. Since then, the entire ecosystem has been written in Go largely for that reason. But this is an independent network tool. It doesn't seem like it has much to share with the rest of Podman. It doesn't seem like we're going to use much like we decided that Rust seemed nice. A lot of members of the team were excited about it, and it's also a better fit than Go for a low-level network tool like this. And you can gain ownership over what we're building. CNI, we never had maintainers there. We never really had ownership over the code. Here, we're shifting the burden to us, but it already largely was on us. And by gaining ownership, by writing this stuff, we have a better understanding of what we need to support. Downsides, we're going to be looking at a major duplication effort because we have to rewrite all that core plugin code, all that core networking code that CNI had. But we looked at the CNI code and we came to the conclusion that we weren't going to be able to reuse any of it anyway, or at least not. It was heavily tied to their plugin model. Looking at it, we would be looking at a rewrite that we would go work. And altogether, it looked like a massive investment, but the potential gains around supportability and around performance seemed like they'd be. We decided to target Podman 4.0 for this. At the time, it was fall 21. We had a target date of early 2022 for Podman 4.0, so we had about a quarter, some time, but not really that much for the work. So, what we came up with was Metamark and Artmark. We decided early on that we needed two tools, and the reason for that is DNS. DNS, you need a persistent service for. You need something that's going to always be up as long as the containers has DNS. You can't socket activate. This is a but Podman in general wants to stay as far away from persistent services as possible. With the DNS container branch, it's right on the slide. So we decided to split so we would have a DNS server, persistent, long running, but optional. You can turn it off if you want to. And a guaranteed running, small, very minimal, quick executing network setup tool. And that allows us to continue our edge focus. We have very, very low resources at idle because nothing is running idle. And from there, we start off with our network setup tool. We named it Metamark. That's the Hindi transliteration of network from one of our Hindi developers. And we also wrote Aardvark on top of that as a DNS server. Names sound similar and they're meant to be used between tools, so it seemed to make sense. Internally, we call them an NV and AV to disambiguate, make them simple. We decided to write in Rust. Again, the team is excited about it. Good fit for a low-level tool. Metamark handles network setup and teardown. It creates bridges, vet pairs, firewall rules, all that fun stuff I talked about earlier. It sets syscuttles in the system to allow routing. And it handles teardown of all those things. And it's written as a model. Again, we don't like plugin model. By slimming everything down into a single binary, we can make it fast, we can make it simple. Then we have Aardvark, DNS server handling container lookups. Anything that's external, it forwards. Anything that's internal for a specific container, it will answer. It's based on an existing Rust DNS library, and we have a single instance of Aardvark per user. So all networks, all containers licensing process. But if you're running Podman as root and rootless, each one of those users gets a separate. So let's talk about the Podman changes that were required to make this happen. So we're not just implementing metabolic hardware, but also untangling our local template, as I said. And we could have done these as separate changes, but both of them had serious potential to be breaking. So we could have done a Podman 4.0 and 5.0 1 month after another, but that would have been really bad for our users. We decided to do them all bunched together as one big change. Made for a more complete Podman 4.0, hopefully more happy users. And from there, we need to make some decisions. First decision, are we going to completely drop CNI, or do we want to retain support? The answer is we want to retain. Network is not going to support everything CNI does. Deliberately. We want to support the minimal use case that Podman does. But there are cool things you can do with CNI. You have a flannel network for your Kubernetes cluster, you want to connect a Podman container to that to debug? Sure, you can do that with CNI. That's cool. I like that. I don't want to break that. So it makes sense for us to retain support for CNI at the same time. Which leads us to next major decision. We want to support them at the same time. This one is a fairly easy no. There are a massive amount of firewall rules involved in making traffic go out to the internet, especially for forwarding. I don't want to make guarantees that our firewall rules and their firewall rules will not step on each other. I don't want to have to write code to disambiguate IP addresses that they are using versus we are using, because there's no actual validation of that. And it seems like it would just be a lot simpler to say you can run CNI or you can run it. And that forced us to make another decision. We were going to have to move Builda over to the network stack. Builda is also written so that we can use networking. And because of that, we were going to have to make it do the same networking Podman did. Otherwise, we risk having build on CNI, Podman on network. And because we are already going to have to modularize networking to allow CNI and network to use at the same time, not that big of a deal. Final decision. Do we want to migrate everyone to network by default? Easy answer again, no. As already said, we are deliberately not supporting everything that CNI does, which means that if you have a fancy CNI, if you have something that we can't support in Network, we would break you if you try to migrate. So easiest, safest decision, don't do anything by default. If you're a fresh install, you get Network. If you are a existing install, you have to deliberately migrate. So, from all these decisions, we went ahead to modularize our networking code. We disentangled CNI from the rest of Podman, moved it into a separate dependency library so it could be shared with Builda, and then we wrote a separate implementation that would talk to the new hardware library. And then we're going to have to make some changes to our database schema. As I said, we have some tech debt in there, assumptions about single IP address, etc. And credit to my coworker, Paul Holtzinger, who made those in a non-breaking fashion. You are actually migrating stuff in the database to new locations that the old version of Podman does not know to look at. So you can take a Podman 4.0 install and downgrade to 3.0. And a few things break. The network configuration has moved, so you lose your static IP set, but you can still start the container, which is better than we were expecting. So, Netabark. Netabark was the biggest problem we were expecting. We can't regress on features versus CNI. We can't have big, gigantic bugs in critical network setup stuff. And we have experience already dealing with the Podman bits. Obviously, we've been developing Podman for a while. We've experienced developing DNS bits. We developed a DNS plugin before. We have never developed a network setup. This is the most intimidating. Fortunately, the core network setup bits not that difficult. Setting up net pairs, bridge interfaces, syscalls, all that's pretty easy, straightforward. All generally match CNI, do what they're doing. It seemed relatively sane. When we found opportunities to improve, we did it. But generally speaking, what they were doing served as a guide. Difficult part's the firewall. If you have ever done an IP tables type an NPL when a container is running, you know what I'm talking about. There is a massive set of rules. Fortunately, there are a relatively limited number of scenarios in which we can generate. Port forwarding rules are the biggest candidates, and there you really only have single port versus ranger ports, TCP versus UDP, same destination port versus change destination. So it's possible to construct a scenario that will test all of these, and that's what we did. From there, we got a test suite to validate Metadata and hardware, and from there, we were able to identify what rules CNI was generating and duplicate them for Metadata. Basically, we are doing a very similar thing to what CNI does, although we have some simplifications, maybe per container rules for NAT, for example, whereas we do per network rules for non-per. Next, we got to look into what does CNI not do. And the big ask there was going to be support for NF tables and power. If you've ever dealt with IP tables programmatically, there is no way to do that. Everything with IP tables, you accept the IP tables binary, parse the output. It's kind of hard. NF tables and FireLD resolve that. So we didn't think we were going to have time. Again, we have a single quarter to develop this, but we were able to build in a modular interface, so we can build in the future support for firewall interfaces that don't suck as that. So let's talk a bit about Aardvark. Network setup tool. It's fairly obvious why we need this. We're replacing CNI, which is the only other tool that really does that task. DNS. DNS servers are dying a dozen. You have DNS mask, you have find. Why can't we use one of those? Why is Aardvark special? Aardvark is usually just a filter like you find anywhere else, but queries for specific containers are dependent on who is asking. Queries are dependent on what networks the client uses. So containers can only see other containers in networks that they are joined. We have a diagram here. Let's look at container one of that diagram. He is a member of all three networks, A, B, C, which means he can see everything. Let's look at container 4. Container 4 can only see container 1 because he is only in container 4 network C. He can only see other containers in network C. Container 5, for example, can see containers 1, 2, and 3, but not 4, because container 5 is in networks A and B. So what we need is a server smart enough to know who's asking, and based on that, what networks they're in, and from that, we can tell what they can actually see. And our initial implementation was naive. We did a per network DNS server. One problem there is that the kernel only resolves with a single server. So let's say container 1 wants to look up container 4, but he uses network A's DNS. He gets an NX domain because container 4 is not in network A. And he just stops looking. He takes that answer as authority. So we looked into potential alternatives to writing our own server. I got 90% of the way there using bind with a whole lot of custom, basically access lists and specific container IPs based on what network we were in, but it was only 90%. So from there, it made sense to do a proper server that actually understood what container is asking, what networks are in. So let's talk about the process for Aardvark. It was the last thing we built because it's the least essential. If we ship without Aardvark and DNS, it's not a breaking change to add it later. That could have been a Podman 4.1 thing. We actually made it, but it seems smart to deliver this way. And it's a bit unique in our stack because it's persistent. Everything else in Podman exits quickly. Aardvark will be running so long as you have a container that needs it. It's also performance critical. While the rest of Podman is sort of performance critical, it's performance critical in the sense that you, the user, are going to run a command and you expect it to run quickly. DNS is a bit more performance critical. It cares more about individual milliseconds. So from that, we originally feared we were going to have to completely reinvent DNS, which means a very scary prospect, but we found a existing Rust DNS server implementation called Trust DNS. It seemed to work, and it did everything we needed, so we adopted it, and it's been serving us quite well. Trust DNS handles the caching name server part of forwarding, so any query that is not for an individual container goes through it. Since it's caching, you actually gain a bit of performance most of the time. And for queries for individual containers, we start off with configuration files that are set up by or network rather. So when a container comes up or goes down, it is added to or removed from config files. And the config files contain every container that's currently running, their IP addresses, what networks they're in, and the total set of networks on the system. And when the config files are changed, we do a hot reload on hard which causes it to cache all config data in memory. It also causes it to, if there's a change in networks available, bind to additional networks. So if we have, say, a new network created, we'll bind to that new network's provision. And from there, since we now have a cache in memory of network membership of the container, what IPs it has, and what container from which network, it's relatively easy to do lookups. I was just doing it in one fashion because everything's in memory. So, briefly, Metaphoric and Aardvark released with Hotman 4.0 on February 17th. We did Metaphoric and Aardvark 1.0 at that time because we felt that they were pretty stable and mature. We've been dogfooding them internally and we were pretty satisfied with their state. But Hotman 4.0 is a breaking change release, so it's going to roll out slowly. It only hit default in Fedora 3.6 in May 10th. Default in RHEL 9, we made it in time for that, but RHEL 8, we can't change things midstream, so we're going to have to keep CNI as the default until end of life for RHEL 8. Again, we were able to sneak Metaphoric in as a tech preview in 8.6. It'll be off tech preview in 8.7, but it's availability. It's in the process of being packaged for Debian. It's been released for a bunch of distros, including Arch. And overall, the rollout has been pretty smooth. I would say at this point, based on bug reports, 2 to 3 in 10 Podman users are using Metaphor, which is about what we expect since existing installs are mostly going to be still on CNI. And we expected a bunch of bug reports when Fedora 36 came out, not gonna lie, but thus far, we are hearing about people, which means, generally speaking, I hope they're happy. Now, just a brief bit on next steps. We aren't finished here yet. Already released with Podman 4.2 last Thursday, the ability to bind a port total of 53 with Aardvark. So we have complaints that Aardvark is blocking port 53 on the host. We only do it on interfaces that containers use, so interfaces. But if you're doing a DNS server that just wants to bind to 000053, it'll break that. So now we have support to bind on non-53 or ports above 53, and we use firewall rules to forward traffic or forward container DNS traffic rather. Also, in Podman 4.2 network isolation, this is a Docker feature that we haven't had for a while, largely because CNI did support it. This is basically containers in one network that is set to isolate and only connect to containers in that network. They cannot connect to other networks. Other things we're working on, NF tables and firewall D support, mentioned that previously. Hopefully in our next release, I'm working on that. Should be done soon. Another thing, DHCP support for the Mac VLAN driver. I didn't mention Mac VLAN, but we do support it. Minus DHCP in the initial release. That should be out soon. All right. So we fix our
Hold on, man. You do that.
Are you gonna put the DHCP support into Aardvark? Or will it be a separate thing?
DHCP port support is in Aardvark, so it should already be here.
Just about the DNS that we said we have plotting multiple networks. Use namespace as the differentiator. How do you do it in this case?
There is no differentiation. We're using the Docker model, which means that you can have containers in 3 networks, both with all of them with the same name, and we will just hand you all their IP addresses. So absolutely no differentiation. It's an absolute mayhem there. If you decide to have containers with the same name, please don't do that.
DNSSEC?
Yes, actually. That was a horror story for me for a while because I thought we were going to have to write it ourselves, but then we found Trust DNS and it supports it already. Thank God I didn't want to deal with it.
And are you using the IP tables compat layer for NF tables?
At present, we're using IP tables and pads. I'm working on a dedicated layer that will use the actual NF table API. So soon TM, that's coming. And hopefully that'll be even faster because IP tables parse things actually.
Again, Michael from me, but I want to ask a question. So I think you kind of answered the question, but if you have different containers on different nodes, do you use any sort of encapsulation to talk across nodes? Like VXLAN, VXLAN, no?
Nothing. We are strictly single node, and that makes things easy. If you want to do that, stick with CNI, and there are various plugins that will help you with it. But Network only intended to work on a single node.
Anybody else before blaming it?
Thank you. No, the question was, are we going to rewrite in Rust? And we talk about it jokingly, but no, there is no chance that we are rewriting that much domain-specific knowledge in a different language.
You know, Rust, I'm just curious, how was the experience coming from Poland?
I like it a lot. I like it a lot more than I do Go. I have always been a person who really likes keeping things constant. Go does not agree with me. I will say that our initial attempts at Netark and Aardvark code were kind of atrocious because we were still learning Rust in the process. This was our first serious effort. There's a lot of refactoring going on to fix our early sins.
I'm curious about the names, where did they come from? Or how did you choose those names? No.
Netark was, as I said, Hindi transliteration of network. And from there, I just chose Aardvark because it sounded sort of similar and I like Aardvark.
Cool, yeah.
How do you do the user space? When you run Podman without root privileges, what do you do for DNS in that circumstance?
That actually works natively because we do it inside the user namespace. So because we're doing it in the unprivileged user namespace, we get to pretend to be root. We can bind to 53. And it only works for containers inside the unprivileged user namespace. So you can't do anything with the rest. Basically, the host can't get a DNS unless it enters the user namespace for Podman Unshare.
So you're running, so let's say you and I both start user namespaces and Mike is running a root privileged one. Does that mean 3 Aardvarks running at that point?
Yes.
Privileged containers about the network, if they run the same user space and they cannot talk to each other, I mean, if you set it like that, is there a way to prevent them from interacting?
If you have 2 different unprivileged user namespaces, they can't talk to each other. But for a single user, they should all be within the same unprivileged user namespace. In that user namespace, we can run Netark, which means we can make bridge interfaces for them to talk to each other. So for a single user, your containers can talk to each other if they're rootless, but 2 different rootless users cannot have their containers talk.
Right, but if it's rootless and you don't want security reason, you don't want 2 containers to talk, but they belong to 2 different pods, for instance, is it possible?
Yes, that's actually the default.
Okay. Thanks.
Containers ones, not container. Laptops want to sleep. I am happy about that. I was a little concerned. Thank you. Oh, yes. Oh.